As Len mentioned, my name's Andrew Johnson. I've been working on the new repeater. One of the major changes is going to be the transition from how it kind of currently operates to using Allstar for a lot of the voting and control functions. So this presentation will kind of give a introduction to what Allstar is, how it's going to be implemented on our new repeater, and how you can use it once we do get the new repeater up and running. So to kind of start, what is Allstar? At a very high level, Allstar is a method to link repeater systems. So there's a couple different ways you can link repeater systems. The first is fully digital. So that's, your DMR where, as soon as you key up, it goes out over the air as a digital signal. It gets received as a digital signal, sent over the internet as a digital signal, and comes out the other end digitally. That's like our System Fusion, D-Star, DMR, all of that. We'll kind of skip to the bottom here and go analog over analog radio. That's how our current repeater is set up for the voting, where it comes out of your radio as analog. It gets picked up by a remote receiver as analog, rebroadcast by that analog, and it's analog all the way. It's kind of a limited distance, and with each hop you take, you lose more and more signal. As many of you know, that's kind of been an issue with the DART with the voter. So one of the things that could kind of address that is analog over IP. And what analog over IP is it's the same radio you use today that goes out analog to the radio. There's a computer on the other end of the connection that's hooked up to the repeater that actually digitizes that analog signal and then allows it to be routed out, through an IP network or the internet itself. You could add internet, you could connect to a PC, connect to a smartphone, and some examples of that are Echolink, IRLP, and Allstar. So kind of drilling down into that, analog over IP. IRLP is a radio to radio only, and it's only run by one guy. So it's not as open source. If he decides to turn everything off, you might not have access to the network anymore. The second is Echolink, which we do have on our repeater today. It's really good for those that, might not have a radio yet. They could get on with the app on their smartphone, talk on our repeater, talk around the world on other repeaters. It's really good in terms of the smartphone interface. I think it's the best out of between Allstar and Echolink. However, it does require having a computer at the site where you're trying to, connect to Echolink. Allstar kind of has some of the same functionality. It's not as good to use on the computer or over the phone, but it's amazing voice quality and it's really good for repeater to repeater links. And the best part is these two you can use on the same computer. So instead of having to have a Allstar computer and a Echolink computer, you just have both of them running as programs on one computer. So what is Allstar itself? Well, for those of you that have worked with PBXs or private branch exchanges, it's basically the phone systems that big companies use, right? Where you say, do you know the extension you want to dial? Press 1 for more information. Press 2 to be transferred to an operator. That's all handled by the PBX software. So Asterisk is an open source PBX software, and it's actually used a lot in business and industry right now to kind of do all that. So some very smart people took that software, added the radio interface layer on top to support stuff that's needed for radio work, and that's kind of Allstar. So at a very high level, it's essentially a telephone-esque linking system for radios is the easiest way to think about it. It does need to run on a Linux computer, so there is some like a learning curve if you're not familiar with Linux. And it could also perform controller and voting functions. So it used to be you'd have to have separate equipment for all of those functions. Now it could all be on one computer. So more about Allstar. When this presentation was made, it was about 1,500 nodes. Now there's over 10,000. I think I just checked it like right before the meeting, it's up to like 12,000 and something active nodes right now. So there's definitely been a huge explosion in popularity, which is really cool. Since it's completely open, you're not beholden to whatever, like the project manager wants. If you wanted to add, like if you built your own node and wanted to add DMR support, you could do that. You can make your own simplex node. So if you wanted to connect to the All-Star network, say you had a cabin up north that, there's no cell service, but you have an internet connection at the cabin, you could put a simplex node on that. And then, for a couple miles around, you'd be able to dial into the All-Star network. There's some huge networks statewide, as well as, local networks. And we're going to use it kind of as our interconnectivity. So this is a diagram on how All-Star works. So you can see here, at the bottom is kind of what you're normally used to. You have your radio, you can key up, the repeater will repeat it to another radio. Where All-Star comes in is you can see the purple arrows pointing to the computer. So it'll take that signal, the computer will take that, route it out over the internet to other repeaters, depending on how you have the system connected. So the summary of linking, we're focused on linking the analog radios to analog radios. There's nothing wrong with DMR. It's a great thing, but our repeater is analog. We want to make sure that everyone doesn't have to run out and get a new DMR radio. VHF around here is mostly analog anyway, so we're kind of sticking with analog. All-Star is really good for linking repeaters to other repeaters, but it's not so user-friendly when it comes to like the smartphone use. But Echolink is really good with that, so we're going to use both. So more on that on our local project. So this is kind of how we're specifically implementing it. Kind of who, what, when, where, why. Kind of the DART team is rebuilding the DART repeater with the grant we got from ARDC. And we're going to convert the remote receive sites eventually to a microwave IP link. For now, we're just going to use the plain old internet. And that way, instead of having the noise come in on the voter links, ideally everyone's going to sound just as good as they sound coming into the receive site. Why? Because we can. It's cool. We got a grant for it. And the FCC wants hams to contribute to the state of the art of radio communication. So some basics on our connectivity philosophy. So we kind of split it between user connectivity and repeater to repeater connectivity. For user connectivity, it's ham radio, so their primary mode of entry is going to be RF. Your HTs or mobiles that you normally have. We do want to add Echolink though, because it is a really good option, and we do have a lot of people that check in via Echolink. So we are going to keep that. One other thing that we're going to add is streaming audio to Broadcastify, which is a kind of a radio scanner website. So if anyone worldwide wants to listen in, they can just go in and do that. Right, so we'll kind of expand our reach. If someone's, looking at police scanners and they say, "Oh, what's this?" W8HP. They'll hear our net and all that. Repeater to repeater is going to be All-Star to serve RF users, since it's ham radio. It works via the internet, or we could also use our own private IP link once that's available. And it is nice and flexible, right? We're not beholden to just having one or two different configurations. Everyone will be able to connect to whatever repeater they want, assuming that someone's not already using it. So this is a very simplified diagram of our repeater and how it works. So you can see here, the repeater will kind of be the only thing that transmits. So however far you can hear with it transmitting at 100 watts is the range. However, we will have a remote receive site. So if you're kind of far away from the main site, you could still get into the system. If you're closer to like 12 and Hoover or City Airport, those sites can pick you up and send your audio back to the main site. There is a module called the Radio Thin Client Module, or RTCM, that takes the analog audio from the radio, or the repeater, digitizes it, encapsulates it in an IP packet, and then sends it to the All-Star Linux PC. and then from there it gets sent over the internet to other repeaters, or if it's in the case of the voter, it's just the voting audio stream that comes over. And in the next couple of slides, we'll go over how the voting works. So this is how we get the signal from the radio to the PC. If you look at the left, you can see the RX audio and PL detect. So the radio will be transmitting the audio, and whether or not it sees the right PL tone. And if the RTCM sees all of that, it'll take that information, digitize it, send it over the in-cabinet network to the computer, where the computer will do, what it needs to do to determine, what audio stream should I be playing. Am I going to play one of the voted audio streams? Am I going to put out echo link, announcement, station ID? So all of that audio gets arbitrated and then sent back through the network, back to the RTCM, where the RTCM converts it from digital back to analog, keys up the repeater, and then transmits it. And I am happy to report last Saturday when we were working on it, we did get that working. So, you could key up and talk into one radio, and then, having another radio, you'll hear the repeater in your voice, with about a half-second delay. So all of that seems to be working just fine, along with the announcements. So that's a good, good progress announcement. So looking into the voting specifically, we'll kind of take a few steps back and say, what is a voted repeater? As you know, a repeater can only repeat a signal that it can hear. So with our location at 10 in Southfield, if you're on, if you're at Lake St. Clair and you key up, it might not be able to hear you. And, most handhelds, you don't have the height on the antenna, you don't have a lot of power, and you don't have a lot of gain on your antenna. So your signal might not be able to make it all the way back. However, if we add a receiver that's kind of closer to where you're at, there's a better chance of your signal getting into the system, and then, the repeater can hear you. However, you could also have the situation where you're heard by multiple sites. In that case, the system has to know, what's the best signal to use. It doesn't want to just do the first thing it hears, because it might be the worst signal. So voting is the process of determining, what signal should I use and should I rebroadcast. So there's just some different methods of voting. So the simplest is you just look at whatever signal has the least noise and choose that one. A little bit more advanced is to look at both the signal and the noise and choose the one with the best ratio. Allstar with the RTCM hardware measures the signal at the receive sites and then sends that both the audio as well as that measured signal strength data over the IP link. So instead of trying to vote on a signal that's been through a couple different radios, you're voting on the signal strength as it's heard, and that makes it a lot clearer and a lot less susceptible to interference or bouncing between the different receive sites. So this is kind of how our current voter works. Theoretically, perfect signal will only have stuff in the vocal range, so below 4 kilohertz. And as you get more and more noise, you have more and more of a high frequency component. So the way that the current repeater works, it just looks for the noise or the signal with the lowest high frequency noise component and assumes that's the best. That's not always, usually that's the case, but sometimes you might run into issues. You might have noise that's being introduced on the RF link rather than that's coming into the remote site. So that's kind of where the drawback is. So IP voting uses the same principle as the noise voting. However, instead of measuring the signal to noise ratio at the main site, it does it at each individual site. So, at the airport or the hospital. And that avoids any influence by the transmission back to the main site. However, to do that, you have to make sure you're comparing, apples to apples and oranges to oranges. So each RTCM needs a GPS receiver to kind of timestamp the audio to ensure all of the clocks are synchronized. And that way you're comparing, your sample at time one to all your other samples at time one. You're not comparing a signal that came in 5 seconds ago to one that's coming in now. The IP link to send all that data back to the main site, it just could be any IP link. It could be Wi-Fi, Part 97, really anything that supports IP. You're not limited to any one transmission method. As long as you could put IP packets on it, you could use it. And then at the main site, you need a computer running Allstar to determine what the best audio is and then send it to the repeater. So this is transporting the signal at each of our remote sites. You can see the diagram is almost exactly the same as it was for the repeater site. The only difference is this is receive only, so there's no audio output going out of the RTCM to the radio. It's just coming in from the remote receiver to the RTCM, out to the internet or whatever IP network we're using, and over to the main site. So this is kind of a diagram of how it works, like in general or in practice. So the Allstar server will take all of the packets it gets from all of the different RTCMs. And as I mentioned before, you need the GPS to determine the timestamp. With IP networks, there's no guarantee that you're going to get all the data in order. You might get the last packet first, and then the first packet, and then the second. So that GPS timestamp is how you could reorder everything to make sure you're playing the audio samples in the correct order. And each of those packets, in addition to the timestamp, will have the signal strength or RSSI, as well as the audio for that sample. So once you have all of these packets coming in, how do you determine, which one's the best? So first, Allstar will put all of them in sequential order and then go through and it will choose the packet with the best signal strength to be rebroadcast. However, to keep the audio from bouncing back and forth to different streams, there is a minimum level. So it'll pick whatever signal is the strongest at first, and it'll lock onto that signal as long as that signal strength is above a certain threshold. So in the example here, it'll pick 75 because it's the strongest at first. It might drop down to 70, but assuming, we say anything over 60 is good, even though that other packet has a better signal strength, we'll stay on the original stream until it drops below a certain threshold, at which point we'll take whatever the best signal is again and, stick with that signal. And that's just, as I mentioned, to keep you from bouncing back and forth and having it switch. If you're at if you're getting in the same to kind of two sites, one's, between 70, 71, one's between 69 and 70, you don't want it to be hopping back and forth if the audio is pretty much the same. So now that, we have all of our signals coming in, how do we vote? So this is kind of just a diagram. You'll see we have two signals coming in, both the red and the purple. The voter is going to say, hey, I like the red signal the best, so that's the one I'm going to send back out. And you can see it'll send it back through the network to the RTCM as it goes out over the air. So control. Many repeaters use a separate controller board for a bunch of tasks, the station ID, playing announcements, linking and unlinking to other networks. Since Allstar's primary purpose is linking audio sources, it makes more sense to just use Allstar for all of that. You could schedule, since it's a full-fledged Linux computer, you could schedule scripts to run whenever. If you want to play an announcement at the top of every hour, every 15 minutes, or 2 o'clock in the morning every day, it's very easy to do. You can make it has a built-in text-to-speech, so it's pretty easy to script commands where you can say, at this time, say these words, and it'll go through and do that, with the pre-net announcements and stuff like that. And one thing to note, we did take the audio files that are currently on the Dart with the all the different call signs, saying their call sign, welcome to the Dart. And we have put those on the new computer. So those will still exist on the new system, just like they did on the old system. So I think the part that everyone's been waiting for, now that you kind of know what Allstar is, how do you use it? And just remember, this is still contingent upon us getting the new repeater installed and activated and all that. If you try to dial this now, I don't know what's going to happen. So don't do that just yet. So the very, very, very most important thing to remember is you have to still ID properly, both on the radio or if you're using a computer or a phone. You're still going out on the air, even if you're on the computer or phone, so you still have to follow the FCC ID requirements. When you're entering commands, you could be transmitting on remote systems. So if if the repeater was already linked to another system and you key up the repeater, you could be going out over that link onto a remote system, anywhere in the world. So with that, it's a good idea to give your call sign before you start entering in the touch tone commands. There is a delay if you're on a computer or phone instead of a radio of about a second. I think it's more pronounced with Echolink. So those of you that know Echolink, I think, are aware of this, but you do have to leave a little bit of space between transmissions. When the link status changes, so if our local repeater is connected to a remote repeater, the courtesy tone at the end of the transmission will change. So instead of making like a beep, it'll make a boop. I don't know exactly what it'll sound like yet. We can modify it a little bit too. We can make it a Morse code letter or anything like that. So if anyone has any strong opinions one way or the other, let me know. It's really configurable. It takes 2 minutes to change, so it's not that big of a deal. If you do initiate a link to a remote node or hub, listen while it's linked, and when you're done with it, make sure you unlink, especially if it's busy, because if you leave it linked, anything that's on that node is going to be coming through our repeater as well. So how to use it, some more details from the radio. You could talk through a repeater that's already been linked by someone else, or you could tell the repeater to link to another system, and you do that by transmitting DTMF tones. And that's just with the keypad on the front of your radio. If it has it, you just key up the push to talk button and then dial the number like you would a phone. At least on my Yaesu, I assume it's like that on the other radios as well. If you want a little bit more convenient way to do it, you could use Echolink from a PC or a smartphone. And again, like I mentioned earlier, if you just want to listen in, we're going to be streaming on Broadcastify. So if you can't sleep at night, want to see what's going on, you could just pull it up on your phone and listen in. So from a PC or a smartphone, I'll kind of go over this quickly since I think everyone has used Echolink. Since any ham can use the radio to radio links, we kind of assume that there's no validation needed, because if you're transmitting, we assume you have a license. To connect with a computer or a smartphone, because anyone could, in theory, sign up for an account and log in, you do have to get your license validated by the Allstar or Echolink teams. And that just makes sure that, everyone that downloads the app and connect to the network is a ham and, is able to transmit. Echolink, you just sign up for an Echolink account, they validate your license, you download the app, and you could use it. For Allstar, you just would have to sign up for an account at allstarlink.org, and the team there just looks you up on QRZ. One thing to note, if you're only planning on talking on the repeater and linking to other repeaters, you don't need to request a node ID or a server ID. The only time you'll need a server ID or a node ID is if you wanted to build your own hotspot or local node so you can connect to Allstar with wherever that node's at. So Echolink specifics, it does require the internet. So if the internet's down, there's no Echolink. It's officially only supported on Windows. However, there's apps on Android and Apple iOS, and there's some unofficial Linux plugins, and that's what we're using for Allstar. So as I mentioned before, a little bit on Broadcastify, it's only a way to listen to the repeater. It'll be coming once we get everything set up and kind of proved out. We'll turn this feed on. You just go to radioreference.com and then live audio, and you could just kind of drill down to Oakland County, find our link, click it, and then be able to listen in. Right now, I think there's only a few other repeaters that are on Broadcastify. I think the Oakland County one is, and W8FSM, I think, is the other one that I've seen on there. So, yeah, that one's on for Macomb County. Yeah. Yeah, I was just talking about the Oakland County for now, because yeah, that one's set up as Allstar too. So that's like what we want to be like eventually, hopefully. So So assume you want to use it from a radio, right? You don't want to use your phone or computer, and you want to use your radio to link in. Um, Make sure that you disconnect when you're done, especially if it's busy, as I mentioned before. And also try to maintain a good signal into it. If you have like a compromised antenna on like the low power HD inside of your car, you're not going to be getting into the repeater very well just because your car is going to be blocking most of the signal. And if you are linked to a node, you don't want your scratchy, really bad audio that's unintelligible to be going out over multiple nodes. You do want to remember to use courteous radio practices. So, listen before you transmit. Uh, if someone's talking, don't just key up and connect to another repeater. Let them finish their conversation. Make sure the repeater's not in use. Then connect. And the other thing too is kind of look before you leap. If you're not sure what you're linking into, there is a receive only mode. And what that does is you can hear the other side, but the other side can't hear you. So that'll kind of, prevent, anything on the repeater on our repeater from going out onto another repeater until it's set to, full duplex mode. So in order to connect to another node, you'll need a node number, and that's analogous to a telephone number. We don't have ours set up yet for the new DART, but once we do have it, we'll publish it. It'll probably be once we have everything tested and working, just to avoid any gotchas with anyone connecting. From a PC or smartphone, you really don't need the node number. It'll just be like a plain English, either a call sign or description. However, on a radio, there's really no good way to look that information up. So you just have to remember the number and dial it in on your keypad. So if you go to allstarlink.org, they'll have a list of all the node numbers. Echolink has its node numbers available on Echolink. And there is a way to call an Echolink node from an Allstar node. So if you wanted to connect directly to an Echolink node, you'd have to dial it a little bit differently. But again, it's kind of analogous to a area code for a phone number. So here's a list of the common commands. So if you want to connect to a node and only hear what's on the other node and not have your audio go to that node, you dial a *2 and then the node number. If you want to connect and be able to talk both ways, you dial the node number, but with a *3 before it. If you want to know what's actually connected, you could dial *70. If you wanted to unlink everything, *71. If you wanted to unlink just a specific node, you could do *1. And if you wanted to know what the time is, you could do a *81. And we'll probably publish a quick guide for this because I know it's kind of a lot to remember. So we'll have like a nice, phone book, as it were. So if you were on, this 442 repeater with a node number of 43078 and you wanted to connect to node 42993, you'd take your radio and key up and say, hey, AJ0WX, and then enter *3 42993. Again, kind of analogous to dialing a phone number. So if you don't hear any errors come back over the frequency, you're connected. And then you could just give your ID again. You'll transmit on both the 442 and the 5317 repeater. And then you could make your call and say, hey, I'm listening. So if you want to talk to someone locally, right, and you don't want to go out over the entire network, you could key up, again, say your call sign to properly ID, and then click *71, and that'll disconnect all of the link stations. If you want to know what's linked, beforehand, you just dial *70. So say you want to, there's a remote hub that you want to connect into that's in Australia, and you forgot what time zone they're in. You don't know if it's going to be busy. You don't know if it's going to be dead. So you want to start listening in before you key up or have anything on the repeater go out. You can key up and then dial *2, 27225. And then anything that you say on the local repeater will not go out to the remote link, but anything that they say on their end will come over. So that way you can kind of listen in, make sure the repeater's not in use, or if it is, to know like, hey, don't key up until there's a gap in that transmission. Once you kind of listen in and say, hey, I want to, connect both ways, you can dial *3 and then the number again in both ways. So if this has piqued your interest and you say, hey, I want to set up my own node for, if I'm, either at home or up north or wherever, you could actually build your own node. And essentially it's analogous to a cordless phone. So you'd have, your hotspot at your house. You can take your radio, key up on that hotspot frequency, and connect to the Allstar network anywhere that you have internet access. So you could build your own. You could do, a nice, just low power simplex node. You could do a full-fledged repeater, which I will tell you is a lot of work. We're building one so you don't have to. And yeah, hopefully it'll work pretty well. But if you start using it and you like the ability to talk almost anywhere, and you say, hey, I don't want to tie up the repeater, you could build your own hotspot and be able to talk anywhere there's an Allstar node from the comfort of your couch. So what do you need to actually build one of these? You'll need a Linux computer running Debian. Really, any old computer works. You could the one that we're actually using for the computer, I think, was new in like 2013, and it wasn't even state of the art back then, but it has more than enough power to do what's needed. So if you have any old computers, old Raspberry Pis, old laptops, it's perfect. Then you just need a way to interface the radio to that computer. They make devices for it. They're a little bit pricey, but it's plug and play. You just have to make sure you connect the radio right. Or if you're handy with a soldering iron, you could buy some cheap USB sound cards. You do have to do some surface mount soldering to pull out the lines for push to talk and all that. So it's a little bit more hands-on. RTCMs are another good option, but if you're not using them for voting system and a repeater, it really doesn't make sense because they're a lot more expensive than the sound card interfaces. And then, of course, you'll need a radio and then the interface cable as well, but those are usually pretty straightforward. You will have to use Linux to get it set up, so there are guides for that. Allstar&TheDart has really good documentation if you did want to set up your own node. And that's kind of how I did everything on the repeater. So everything that I know about Allstar, I've kind of taught myself over the past few months. So the website's great. There's forums with really good people on there. If you have questions, you usually get an answer within like 20 minutes. It's not really hard. It's just different. So it is definitely a interesting thing to kind of learn more about. So with that, that's all I had. If there's any questions on any repeater specifics or anything else on Allstar that I might know, I might not know. So I might tell you to, make a form account and go online. But, yeah.
Yeah, I've got two questions for you.
Yep.
First, if I'm a Gabby guy and start talking a long time and I'm on a node and I hit the timer and the computer shuts off, what happens?
So that depends on each repeater's individual settings. So I think on ours, I have to double check to see how it's set up, but it has like a 3-minute timeout timer. So through and essentially stop playing the audio until it sees the unkey, and then it'll let you key back up after that. On the remote nodes, it depends on how they have it set up. You might have you might run into an issue where if they have like a short timeout timer, you'll be still transmitting on all the other linked nodes, but they might time out theirs, and so you only be going out on 2 of the 3 or 1 of the 3 or something like that.
Okay. Second question is, if we're going to have the remote stations going through the internet, what happens when the power goes out? Do we lose those?
So yeah, it depends. I'm not sure how they're set up today, if they have battery backups or not. If they do have battery backups, as long as we have a network connection, we're fine, which is why we want to migrate to the IP over microwave links in the future. But everything's set up in such a way that as long as everything powers back on, there's no configuration or manual connection needed. It's pretty robust in terms of, if even if you have like a blip in power, where if there is like a standby generator where, okay, the power is out for 5 seconds as the standby generator comes back up, it'll essentially lose connection and then reconnect once it has the ability to contact the main site.
I'm not sure whether, well,
Yeah.
the building that, the repeater is in does have vertical power. I'm not sure whether we're hooked up to that, but, anyway, that's a possibility. I doubt if the roads have, vertical power.
Yeah, and so one thing to note about that is there's different levels of kind of failover built in. So if we lose any or all of the remote sites, there's really no impact other than we can't get any data from them. The main site will still function as normal. So say, for example, City Airport loses power or, site there goes down, everything else will still function just fine. If we had a, say, catastrophic computer failure or anything like that, the RTCM will default, that's hooked up to the repeater, will default to a in-cabinet repeat. So you at least have a very basic repeater controller that'll still just do a local repeat. So you only have like the main site and you lose all of your Allstar connectivity and all of that, but the repeater itself will still work. So
Okay.
that too on Saturday. So
WBNSBI has a question here. I'm on Zoom. Is there provision that someone brings up a link, they're using it, and then they go away, so they never turn it off? So is there a provision that if on the Dart side of whatever somebody did on the Dart, when it's not receiving a signal from either the main site or the remote sites for, say, 10 minutes, and I'm just picking up a number here, or 30 minutes, whatever, it's going to automatically deactivate the link. The purpose of that being that someone just can't turn on a link and go away and it stays hours and hours and hours.
Yep. So kind of a little bit of clarification on the links themselves. The RTCM and voter links are a local link. So those will always be connected regardless of activity. In a case of linking to a remote system, say, we wanted to connect to a repeater in California or something like that, connected to the repeater, talked, and then kind of left it and left it connected without any activity. There is a inactivity timer where after a configurable period of time, it'll disconnect all links unless you have an exception put in. So
Right.
if we wanted to link to the our UHF, we could put in a persistent link there where even if there's no activity, it'll still allow that link. But everything else, if there's no activity going to or from that link, it'll time out after a certain period of time and disconnect.
Right. Just to clarify, someone activates a full transceive link between here and California, and then they go away or they just don't say anything. But after a certain amount of time, we're still receiving data from California. So in that respect, the link, the train, we're still listening to California. So it's not only, my question is not only the fact that whoever in Oak Park stops transmitting, but also when that link goes away, that they're not transmitting, that the receive link from California will also go away after a certain amount of time. Is that correct?
Yeah, as long as there's no traffic to or from, it'll disconnect.
So when you say to or from, okay, so what that means is somebody could activate a link. They're not transmitting here. They're in Oak Park. They're not transmitting at all. But 12 hours later, if that link is still, if somebody in California is still transmitting, we're still going to be receiving it and putting it out over the Dart. Is that correct?
Yeah, so if someone connects to a remote repeater and that remote repeater keeps keying up, that link will stay active because there's activity on it. If the link is dead and there's no activity on it for, I want to say it's like 5 minutes or something like that, it'll disconnect.
All right. Next is a request. These slides were really, really good, and thank you for putting them together. And the request is, can we get them put up on the Hazel Park website, please?
Yeah, sure. I could send yeah, I think the presentation will be on YouTube. So, and that'll be good for the short term. And then, yeah, I'll send the files over to Ken to put up.
And the final comment is, or question is, when you are on Broadcastify, that thing can pick up not only amateur radio, but it could pick up, say, Michigan, Oakland County Fire Service or something like that, which is not an amateur radio system. So is there any filters on that system such
Yeah,
that?
it's receive only. So we basically push audio to Broadcastify, but we don't get anything from them. It's just we push our audio to them and that's it. We don't get anything from them.
Okay, thank you. And that's all I had at the moment. Thank you. Again, very good presentation.
Any other questions, comments?
I'm gonna use a repeater every week, just once a week. Every day. Well, we know about you, Leslie. Very good. Oh, this. Great presentation.
The smartphone app we talked about being difficult for the Allstar.
Oh, so I copied the presentation from a guy that posted it back in 2016 to share. And that's what he said back then. Is it good now? Okay, I think there was like a All-Star specific one, but I think DV Switch has kind of fixed a lot of the drawbacks.
Sometimes you don't know because you're on your phone, you're not on radio, and you try to connect. There's any traffic on the computer at that particular time.
Yeah.
Right, give it a minute.
Yeah.
Please repeat the question. We didn't hear it. Didn't come
Oh,
over.
yeah. He was just asking about the smartphone app. The original All-Star app, from what I've heard, wasn't that good, but other apps like DV Switch have improved capability.
This is the name of the app, DV Switch? Yes.
Yeah, DV Switch.
Andrew, DV Switch for Android works excellent.
Okay, it's good to know.
If I install the DV Switch for the smartphone, would I be able to connect to, say, the East Coast Reflector Morning Brew? Yes.
Yes. Yeah, so the question was DV Switch, can you use it on the phone app to connect to, East Coast Reflector? And the answer was yes.